All right. Hello, everybody. So let's make our video for probably the most important unit of the semester, and that is going to be substitution method. Substitution method is the thing that you have to get out of calculus 2. Integration by parts is a good second, but substitution method, when someone says, I've been through calculus 2, I expect substitution method. Everything else is secondary or tertiary or whatever. Substitution method is the most useful thing to get out of calculus 2. It never goes away. Okay? So we are breaking this lesson into 3 smaller lessons. I'm going to record it all at once and just hit the stop button when I get to the right spot and break it into 3 pieces. And all your homework will be broken into 3 pieces. But this is the most important thing to get out of the entire semester. Okay, so this is a big deal. So substitution method, why is it such a big deal? Well, so far we have mainly been taking the antiderivative or the integral of nice things. A letter to the second power, e raised to a power, a trig function of like 7x. We haven't had to take the integral of something complicated yet. And that is where, if you talk to people who have had a lot of calculus classes, like if you asked me what my math specialty would be, I would say calculus, derivatives, differential equations. We would say derivatives are easy, integrals are hard. And the reason for that is because when you get into complicated functions, finding the antiderivative of that is a pain in the butt because you are working backwards. You're trying to undo a whole lot of stuff that's been done to it. And so derivatives are like walking downhill. Can it be dangerous? Yes. Can it be a pain in the butt? Yes. But is it generally easier to walk downhill than uphill? Way yes. And walking uphill can be a pain in the butt. Just ask anyone who's ever tried to climb a mountain. You hit rocks, you hit sinkholes, you hit uneven terrain. It can be a very big deal. Now, the key is knowing when you have to use substitution rule. On something like this right here, a normal math textbook would tell you that you have to use substitution rule on this, but you actually don't. If you've got a parenthesis raised to a power, you can instead choose to FOIL that out and get that exponent out of the way. So I could do the FOIL method on this one right here and get 4x squared plus 12x plus 6 dx and be done with it. And now I'm back to a nice straightforward problem that we worked the other day. I'm just going to use power rules. So all of these exponents will go up by 1. And I will divide by my new exponent. And this will give me an answer of 4/3 x cubed plus 8 x squared plus 6x, and let's not forget our plus c. So if you have a parenthesis raised to a power, that is an option. When you have something a little bit more complicated though, like a square root, that is not the case. You're not going to be able to FOIL away a square root. You're not going to be able to FOIL away a trig function. So when you have a parenthesis that's something you can't really get rid of, that is when things are going to go haywire on you. So right here, the first thing we have to do is remember that the square root is really the 1/2 power. So there's not going to be some nice easy trick like the FOIL method to get us out of this. We're going to have to use substitution method. Okay, and so substitution method, when it's not a nice easy function, substitution method is your first and best option. If substitution method doesn't work, then there's a couple other options you can use, but it starts to get pretty bad pretty fast. So let's actually talk about substitution method. The first thing is substitution method is a multi-step process. You've got the substitution part that's a 3-step process, and then you've got the integration part that I'll do over here. But you have to do the substitution part first. The first thing that you're going to do is the piece inside the parenthesis, the entire piece, not just part of it, the entire piece is going to be replaced. So we're going to let the letter U be equal to that entire mess that we really wish was not there. So the first thing I'm going to do is get rid of that. And so let's go ahead and look and see what that gives us. That gives us the integral of U to the 1/2 power dx. So I've went ahead and converted the square root to the 1/2 power, and I've gotten rid of the 2x plus 3. So already this problem looks 80 times better. Now we've got one thing left to do. This is the letter U. This is still a dx. They don't match, and that is not impossible, but a major, major, major problem. So that's what we have to do with the rest of the stuff in this box. So we've taken care of the first step. Now we're going to take the derivative of both sides. du equals 2dx. Okay, so all we did is take derivative. Okay, so that is step 2. Step 3, we are going to get the dx by itself. So that's going to be 1/2 du equals dx. So get dx by itself. And now, I'll give everyone a second here. Here's what that allows me to do. So in those couple of steps, I now have this. I have the integral of u to the 1/2, and that dx is now 1/2 du. So I've converted everything over into u's. Remember, if you've got multiplication, you can yank that all the way outside. And so that's 1/2 times the integral of u to the 1/2 du. Now I can just do power rule. No big deal. I've substituted everything out. I've condensed my problem. I've made it way simpler. And so now all I have to do is add 1 to my exponent. And that's going to give it the 3/2 power and divide by my new exponent. Let's not forget my plus c. Now, when you divide by a fraction, that turns into multiplication by its reciprocal. The 2's are going to cancel out, so this is going to equal 1/3. And I'm going to go ahead and plug my 2x plus 3 back in. To convert it back over into the letter x. And so right here, is my final answer. So there we go. I have completed a substitution method problem. Any questions about this one? Any questions at all? All right, so let's look at this one right here. Now you could, if you wanted to, do FOIL method on this to the 5th power. I strongly and highly recommend you don't, but you could if you were in trouble and you did not know substitution method. The first thing I'm going to do is I'm going to take everything inside of the parenthesis. And when I was in Calculus 2, this was the hardest thing for me to get about substitution method, was what exactly was I letting the letter U be? Was it the 3x? Was it the 7? Was it 3x plus 7 to the 5th? Where did it stop? And so that's why I'm trying to break it into pieces for you guys, individual lessons, because there is really 3 rules. There's a rule for parentheses, a rule for exponents, and a rule for fractions. And those rules do not all match each other. So you have to recognize the situation that you have so that you know how much to get rid of. You get rid of too much and it doesn't work. You get rid of too little and it doesn't work. There is a Goldilocks moment for substitution method. And even then, it may not work and you'll have to move on and try integration by parts. So I'm going to let the letter U be equal to the entire inside of the parenthesis. So when you've got parentheses, the entire parenthesis, the inside part, is gone. Okay? Then I'm going to go ahead and do du is equal to 3 dx. So that's step 2. And then I'm going to move that over. And so that's going to be 1/3 du equals dx. I told you guys last week I'm going to be a little bit of a stickler about remembering your d's. This is one of the reasons why. They give you so much information. If you leave off your du or your dx, you're going to confuse yourself. You're going to put things in the wrong spot because you didn't label them correctly, and you're going to end up in a world of hurt. And it only gets worse because this becomes even more important in Calculus 3 and just as important in Calculus 4. And so this never goes away. You have to be very careful, methodical. And so now I can replace everything. And so this will be the integral of 8 times u to the 5th power times 1/3 du. So remember, if it's multiplication, you can yank that outside, so that 8 is going to go outside, the 1/3 is going to go outside. So this will give me 8/3 times the integral of u to the 5th power du. Boom. So in just a minute or two, I have taken this complicated problem and I have simplified it all the way down to 8/3 times the integral of u to the 5th. No big deal. Now I'm going to do the power rule. So the exponent is going to go up by 1, so that'll become the 6th power, and I divide by my new exponent. Let's not forget our plus c. Okay? The 6 and the 8 will reduce. So this becomes 4/9, and I'm going to go ahead and plug the 3x plus 7 back in. Plus c. And so I found my integral. Now technically this could be the antiderivative. The integration typically usually refers to you having a start and a stop, and you integrate that through and you get a final answer. When you have a plus c, it's usually referred to as the you really have found the antiderivative. Okay. Any questions about this one? Any questions at all? Okay. Now I'm only doing a handful of examples because it is pretty straightforward. Okay? Once you get it down. So right here, same thing, the entire inside of the parenthesis. Boom. And so that's going to be u is equal to 5x to the fourth plus 1. So that is all right here. I am going to now take the derivative of that. So that's going to be 20x cubed dx. Now again, if you take too much away, that derivative gets very complicated, and it, instead of simplifying the problem, makes the problem bigger and worse. And so that's the art form. How much do I take away? How much do I let be equal to u? And for parentheses, it is the entire inside of the parenthesis. No more, no less. All right. And so now I'm going to move this to the other side. So this will be 1 over 20 x to the third du is equal to dx. All right, so now let's go up to here and let's plug that in. So that is x cubed times u squared times 1 over 20 x cubed du. Okay, let everyone get to here. Now I'm going to talk to you guys about something that is going to be extremely important in Calculus 3. So I'm actually going to do this in more steps than I would and normally anticipate doing it in. Let me switch to a different color here. This problem is all about u's. Anything that's not a u and is doing multiplication can be yanked out front. So these x's, because I've switched it over to du, these x's are no longer live. They are now no more than regular numbers. They can be transferred out front. They can be moved away. They are no longer actually the live letter, and we're not going to deal with their exponents. We're not going to deal with them at all except to cancel them out. And so that's another reason why being careful labeling your d's is very important. So that's going to be x cubed over 20 x cubed times the integral of u squared. Now, I also want to stop right here because this is something that I do want to write something about. Let me switch to the, okay, right here. Let me go over here and write a sentence. If the x's do not cancel out completely, then substitution method did not work. And we need to try something else. Okay, so that's where something like integration by parts would come in. And honestly, the vast majority of Calculus 4 differential equations is more ways to deal with this. So let's say that integration by parts didn't work. What do I do now? Well, have you tried this? Have you tried that? So there's a few more techniques that we could try that we'll learn in Calculus 4. All right. So let's look at this. So this is going to cancel out, which is great. So that's going to be 1 over 20 times the integral of u squared du. And that's going to give us 1 over 20 times u to the 3 over 3 plus c. Going to go ahead and put in my original 5x to the 4th plus 1. So it's 1 over 60 times 5x to the 4th plus 1 cubed plus c. So right here is my finished product. All right, so let everybody get up to here. See if we have any issues about this one. One step at a time. When I was in Calculus 2, I hated substitution method because I didn't understand how much to take away. Most Calculus 2 textbooks, and I say most just because I haven't seen all of them, so I'm sure there's some outlier out there, but all the ones I've ever seen, they treat it as one big thing. They do like one example of each type. They never tell you that it's different types. They make it all seem like it's one thing. And then you're like, I don't understand a rule. I don't see a pattern because they didn't explicitly tell you a pattern. I do dislike textbooks that forget that their job is to give you information, to explain a technique or a skill, that you don't already know it, that you have not seen it, that you are learning it for the first time. And I do dislike that. Math books are very bad about that kind of stuff. Okay. All right, so let's move on to the last example of this type, and then we will move on to the next problem. So let's do a trig function. And this is one that gives people a lot of trouble. They look at this part right here and they want to get rid of the whole thing. No. What's the theme that we've been talking about? The theme is you get rid of the entire inside of the parenthesis, not the trig function. That's the mistake I always made. I hated trig. I wanted it gone. I would be like, u equal to something, and then it wouldn't work. You can't be too greedy on substitution method. It's Goldilocks, just enough to get everything to go away and then work your problem, okay? So I'm going to let u equal x squared plus 7, all right? So that means that du is equal to 2x dx. Move that 2x to the other side. And that gives me 1 over 2x du is equal to dx. Boom. And now I'm ready to go. I'm ready to get everything canceled out. I'm ready to get this back down to a problem we worked last week. Nice, simple problems. You know, Calc 1 problems. No big deal. And so I'm going to go the integral of 10x times sine of u times 1 over 2x du. So the 10x and the 2x can come out front because they are no longer live letters. So they're now free to move about. And this is going to give me sine of u du. Okay, so this simplifies to 5. And if you look at your integral table, sine of a letter is going to be negative cosine. Don't forget r plus c. Plug the original back in, so that's negative 5 cosine x squared plus 7 plus c. And that's a horrible looking square. Let's see if I can do a better job. There we go. And there's my finished product. No big deal. All right, so that is substitution method when dealing with parentheses. I'm going to stop the recording right here, pull up the stuff for the next one, which I think is fractions. Actually, this whole thing was mislabeled. I just noticed that I left the word fraction in the slide for each and every one of these. I'm not redoing the video. That's just how it's going to be. But I just do notice that. So be careful about that. That's where you get into trouble when you copy and paste slides, change the content, but forget to change the title. So be careful about that when you're doing your own papers and slides. It does seem just slightly unprofessional. So do keep that in mind. All right, so I'll see you guys on the next video. Where's the stop record button? Right here. Yes, stop recording.